Hey guys, in today's video I want to show you how to transform any geometry as a cloud simulation in Houdini, so let's dive in. So the first thing is to add a new geometry node. So you can dive inside, and here I will use a file node to import an external geometry in Houdini, but of course you can use any 3D model as an input. So here we can press P to open the parameter of this node, and here I will click on this icon and I will go to $heap, and under my geo folder I have my geometry here in FBX. So for now my geometry is quite big, so let's add a match size node. So here with the match size node I will put the justify Y to minimum and I will click on scale to fit. In that case I have the bottles correctly placed on my scene. So now I will add the UV quick shade just to have a preview of my labels. So here on the UV quick shade I can select a texture here, so I can click on these icons, and under $heap and $text I have some texture for my bottles, and I will select the base color. So here I will make a little rotations on the y-axis to make this one align with the x-axis. So to do that, let's add a transform node. And here I will make a little rotation of about something like 25 degrees. So to transform this geometry as a closed simulation, we can use a sub attribute like an infection effect on the bottles, and then we can use this attribute to create the Vellum closed simulations. So to do that, we can create a first group. So this group will be our start point for the infection effect on the bottles. So here on the group, you can rename it something like start point. And here we can change the group type from primitive to point. And here in my case, I will put my point number 0, which is a point on the bottom of the bot. But of course, you can select some points manually. So to do that, you can select this little icon, and here you can select the point you want to put in the group. So in my case, I will put my point number 0. So now let's add a connectivity node. So this will be useful later when we will use a point deform after the Vellum closed simulations. So let's add the connectivity node, and let's keep the connectivity type to points, and we have the class attributes for each individual pieces. So in my case, I have only 2 pieces for this geometry. So now to create the infection effect on the bottle, you can do that with multiple ways, but in my case, I will use the mob spread falloff, which is a node I really like to use. So here on the mob spread falloff, you can define a start point group. So in my case, I have created a group for the start point here with a group 1, and I've called it start point. So you can just select this group by clicking on these little icons, and here I have my start point. So now you can visualize the mobs falloff attribute by clicking on this little preview falloff. And here you can go to the animate tab, and you can put some keyframe on the spread value. So here at the frame number 1, I will put the value of the spread at something like 1.13. I will click on Alt and left click to add a keyframe for this spread value.
Imagine having access to over 40 hours of exclusive Houdini tutorials, and that library keeps growing every month with brand new content. On Arda Labs, you'll find in-depth Houdini tutorials covering motion design, simulations, product visualization, and more. Plus, you get access to all project files so you can follow along step by step. And right now, we're offering an extra 20% off the annual membership, on top of the 10% discount already included when compared to the monthly plan. This exclusive deal is available for the first 30 people, so don't miss out. Click the link below. Your 20% discount is applied automatically. Secure your spot before it's gone.
And now I will go at the frame 120, and here I will put the spread value at 0. So here to add another keyframe, you can press Alt and left click one more time. So here you can select the mob spread falloff. You can go to the animation tab, and here you can press H to center this animation curve. You can select these 2 keyframes, and here you can put that to linear. So now you can go back to the scene view by clicking on this, and here you can use the mobs remap falloff. And here you can invert that. So you can preview the new falloff by clicking on this. And here you can reverse the mobs falloff attribute by clicking on these little icons, and now you can see that we have this result. So by default at the frame number 1, the mobs falloff attribute is equal to 0. And when the animation starts going to the frame 120, that we have the mobs falloff attribute taking the value at 1. So when you can see that the original color start to appear, so that means that the mobs falloff attribute is coming to 1. So now let's change the position on the y-axis just a little bit. So let's add a transform node. And here we can put the value at something very low, something like 0.005. So in that case, we don't have the bottle perfectly on the floor. So now let's add an attribute delete. And here with the attribute delete, I will delete my ID attribute because I have some ID attributes on my geometry. So now let's convert this geometry to triangles. So to do that, let's add a remesh node. And here with the remesh node, we can put the target size to something like 0.015 to get a bit more resolution for the Vellum simulations. And now let's add an attribute wrangles and let's create a new ID based on the point number. So let's type e at ID is equal to e at pitchy_num. So now we can transfer the class attribute that we have created with the connectivity node on the original geometry here. We can transfer that to the new remesh model. So to do that, let's add an attribute transfer. And this can be useful for the point deform at the end after the Vellum simulations. So you can plug that to the first input and you can plug that to the second input of the attribute transfer. And here you can go to the point and you can transfer your class attributes. So now let's add a null to specify this is our remesh model. So you can rename it something like remesh. So now let's add another null. And for this one, we can call it something like out attributes. And we will use that in the Vellum solver. And let's take this and let's add a null. And this is our original geo. So we can rename it something like orig geo. So now let's create the Vellum simulation. So we can start by adding the Vellum configure close constraints. So you can plug the remesh model on the first input of the Vellum close constraint. So here you can play with different value for the stretch and the bend, but in my case, I will reduce this value to 0.01. And here I will decrease the bend value to maybe this one. So now we can add the Vellum solver. And here with the Vellum solver, we can keep everything by default, but if you want, you can play with some settings. So in my case, I will just go to the first tab and I will decrease the gravity to 0. So now we have everything in place. So in the Vellum close constraint, you can see that we have a group for the stretch and we have a group for the bend. So basically we can target our stretch group here inside the Vellum solver and we can manipulate the close based on the attributes that we have created in subs. So here we have, for example, our mobs falloff, and you can use that to drive our Vellum close simulations. So you can copy these nulls, out attributes, Control C. Now you can dive in the Vellum solver and here you can add the Vellum constraint properties. You can plug that to the source and here you can target a group. So in my case, I will target the stretch group. So here you can enable the rest length scale and you can go to the input tab and here you can import the null that we have copied on the SOP. So here into input 3, you can select SOP and you can paste it here. So in that case, we can get access to the attribute inside the Vellum solver.
Ready to level up your Houdini pipeline? Get the Houdini script pack. Complete toolkit, 7 powerful tools today, plus every future release with free updates. Save time on composition, geometry splitting, material creation, and more. YouTube subscribers get 50% off with code TOOLKIT. Click the link in the description and transform your workflow today.
So here we can manipulate our rest length scale value based on the attribute created in SOPs with this input. So to do that, you can use a vex here. And let's start by importing our falloff. So we can create a new float and we can call it something like falloff. So you can name it as you want. And here you can type points. And here you can type 2 for the input 3 because we have the input 3 here. Now you can type mobs falloff attribute because this is the attribute we will use for the rest length scale value. And here you can type add pitchy_num. So now let's remap this value with a minimum and a maximum. So we can make it something like falloff is equal to fit. And we can remap that to falloff from 0 to 1. And you can create a slider for the minimum. And you can create another one for the maximum. So now we can update the rest length scale value based on that. So let's type rest scale times equal falloff. And here we have the result. So to create these 2 parameters, you can click on that. And in my case, I will put the minimum at 1 and the maximum at 2. And here I have made a little problem here. So you can remove that and everything is good. So now you can see the result of the simulation by clicking on play. So now you can see that the bottle is starting to be a Vellum close simulation based on the mobs falloff attribute. But now we can add some gravity to our simulation based on the mobs falloff. So to do that, you can go back to the SOP level by clicking on Geo. So here you can add a time shift node. And here we can delay our mobs falloff just a bit. So you can type $f minus 20, for example. So you can choose any number if you want. And now let's add another null. So you can copy the name of this one. So you can Control C and paste it here. And you can rename it out attributes 02. So here you can Control C on this one and you can go back to the Vellum solver. So now you can add a pop force. So you can plug that to the forces output. So here you can go to the input tabs of the forces to import the nulls that we have copied on the SOP. So you can go to input 1, you can select SOP and here you can paste it here, out attributes number 2. So now you can go to this little icon and you can use vex to create some forces based on these nulls. And here we can type float falloff like before. And here you can use a point function to get access to the mobs falloff attributes. So let's type 0 for the first input. Let's type mobs falloff for the attributes. And let's type at ptnum for every point. And now let's set the force based on that. So we can type force is equal to, let's say, set. And we can define a value in negative on the y-axis to create some gravity. So we can put 0 on x-axis. We can put something like -2. You can play with different value if you want. And you can multiply that with our falloff. So Ctrl-C here, paste it here. And you can type 0 on the z-axis. And now let's see the result of the simulations. So now you can see that we have this result, but of course I forget to add my ground on the Vellum solver. So we can go back to the SOP. And here you can go to Vellum solver and you can go to the solver tab here, and here you can enable the ground position. So by default, the ground position go to 0. So now we are good for the simulation. So you can enable the Vellum solver and we can maybe simulate something like 72 frames. So now we have this result because I've added the ground plane. So now to deform our original geo based on that, you can use a point deform node. So here you can plug the original geometry on the first input. You can plug the rest remesh geometry on the second input, and you can put the deform geometry on the last input of the point deform. So now let's see the result. So we have that. So on the point deform, you can play with different settings if you want, but maybe you can decrease the radius to something like 0.015. And here you can select the piece attribute, which is class attribute. So in some cases, it helps to have a pieces attribute to get a better result for the point deform. So now you can add a subdivide node after the point deform. And here you can subdivide maybe 2 times. And now you can see the result. Of course, you can always play with some settings on the point deform. So here you can add a file cache if you want. So you can rename it something like out close sim. And you can put that to explicit, and you can create a cache folder and $os folder, which is the name of the node. And you can put that in cache for, let's say, something like 144 frame. So right click, delete channel, and put 144. And here you can click on save to disk. So now you can add some normals on the geometry. So let's add normal node to recalculate the normals. And now let's add a smooth node, and you can add a null to specify this is the output. So you can rename it something like out close. So that's pretty much it for this tutorial. I hope you enjoyed it. You can download this project file with a link in the description. See you in the next one. Bye bye. That's it for today, guys. Thanks for watching, and don't forget to subscribe to our channel and check artivoxer.com to get premium 3D resources. You can access to this project file with our Artifiles membership. See you in the next one. Bye.